Welcome back to ArmanisMath. Our lesson today is going to be about properties of exponents. Actually, let's talk about what we're going to have today. We're going to go over the warm-up, objective, real-life application of what we're learning, the lesson, the practice, and then the quiz yourself within the lesson, 1 minute of hope with Armani towards the end. This is a warm-up, and let's spend about a couple minutes. If you're watching this after the fact, make sure that you pause the video and then at least give yourself 2 minutes. Okay, you guys could use either the live stream chat or also the other one to answer questions. All right, so I'm gonna, or obviously your cameras as well. Go ahead and give me the answer on the camera or in the live chat. Give me the answer for number 1. I see that, Lani. It's much easier when you have a whiteboard, so I could look at issues. That is true. Please do not use a calculator for this one. I see that again. Good job on the whiteboard there. Okay. And good job on the chat. I see that. And how about number 3? Can somebody give us number 3? Okay, I see some discrepancies in number 3. A couple of you have, if you could just give me a fraction, improper fraction, not a mixed number, that would be great. Okay. I see that. That is good. Yes, that's true. How about the last one, number 4? Objective today. Student will be able to use properties of exponents to simplify expressions. Please go ahead and pick one of these words in your in the chat. Give me one of these words in the chat. Come on, you give me a 2 as a word. Ah, you guys. Okay, Evelyn, I got that. All right, here we go. A real-life application of exponents or properties of exponents. So I have one example here for you. For example, you use properties of exponents to label, I guess, or to identify long distances, and particularly like distance between planets, for example, here, large distances. So between Earth and Moon, we have 1.5 times 10 to the 11th power meters, which is pretty long. Who's gonna sit down and write 10 times 10 times 10 times 10, 11 times? So feel free to Google some of this and see if you could find any real-life applications of exponents, and you could paste that in either chats, so we all can benefit from that. The very first note I have here, and if you guys remember, I was a little bit again detailed in me asking you to have neat notes for purposes like this. We have here basically a font that has the main font, which is the A, that's the main font, and then we have a superscript, which is for the power or the exponent. So the main font is A, and then the price one. So down the road, we're gonna have something like this: log, and then let's say I have a 9, which is the main font, and then you're gonna have a superscript, let's say 3, and then you have also an underscript down here. You're gonna have, for example, 3. So if you're not careful in your note taking, and you put these on one line, that's not gonna get you anywhere. That's why be very careful when you take notes. Make it colorful. This is 3 different levels of of font here. See, 3 different levels: underscript, script, superscript, and they all mean different things, so they're not the same. When it comes to powers, A again is the base, or you could name it anything you'd like. You could put B, and or the exponent. And by the way, if there's no exponent, there's always a 1, and here's that hint down here. If there's no exponent, the exponent is always 1. So that's why, if you guys remember the linear equation and linear functions, I say y equals mx plus b, and mx plus b doesn't have any exponent on top of the x or the y, so that's why we call it a linear function. The exponent is 1, even though you don't see it, but it's there. Jalissa, I heard that multiple times today. Okay, so for now they're gonna be part of the video. All right, I'm gonna hide with a curtain here. Take one thing at a time. Let's take a look at this. There are correct and incorrect things when it comes to exponent and expressing exponents and rational expressions. Here's some correct ones. The first one on the left is correct, which is, if I said 5x squared, the base is x. The base is x. It's not 5x, since 5 is multiplied by the x. Look at this one. 5 is multiplied by the x, and I see no parentheses here. So 5 times x here. But the base is x. So basically, the base belongs to the bottom of the power, or the exponent. Not attached to it. Not something that's neighbor. In this case, the base is x. Look at the incorrect one here. So a student, for example, have thought that 7x squared has a base. The whole thing is a base. That is not true. This is not correct. Okay? So I'll make sure that you okay, I got that, Gillis. And the next one here, make sure that you're taking these notes, Gillis. The next one here is this example, which is correct. I've got -2. Please pay attention to the parentheses here. -2y to the second power. The base is -2y because it's in the parentheses. Okay? In the parentheses. That's the whole base. On the right side here, it says 3x squared y. This person thought that xy is the base, which is not true. That is not true. xy is not the base. Only x is the base here. Last one is here, and this one says on the left side, this is the correct side. This is the correct side. I have negative outside the parentheses, and then I have 4x squared, 4xy quantity squared. So the base for this one would be 4xy. Anything in the parentheses is part of your base. Now look, take a look at the left side here. I should say this side here, this left side, right side. 6x squared to the second power, and the base is not negative because the negative was outside the parentheses. So this is not correct. If you want to make this correct, then the negative should go away, and that would mean just you looking at the parentheses. So you really, if you want to include negative in the parentheses, it has to be inside the parentheses, just like this example. It has to be inside the parentheses to be labeled as the base. I'm gonna ask one more time, please, to stick to the notes right now. My eyes are able to see the chat. I need you to focus on the notes. What you're doing right now doesn't really help. I got the point, and we have to move on. Please pay attention to the notes. Okay. So those who have the whiteboards and able to, which all of you should be able to, just show me the whiteboards and tell me if the following I have an expanded exponential form 5 to the second. When you expand that, it's 5 times 5. Now, initially I said there is no need for us to really write like, for example, if I said I need to have, for example, 5 times 5 times 5, 10 times. Well, there's no need for that, but perhaps in certain cases I just have to show what's going on. And that's when the expansion would come to the game, okay? So for example, this one here, there would be a need for this, so that's what I did. Here's another need. If you need to have the exponential form negative 2y to the second power, you know the base is this, so you basically expand them just like that. I've got negative 2y, and then another negative 2y. That's how we expand it. This is exponential form, expanded form. Last one. This is the exponential form to the second power, and I expand this one, and I have I'm gonna say there is something missing here. Tell me what is missing here in the second. I'll write it for you. This is number 1. This is number 2. Tell me what I'm missing in number 2, and particularly I'm talking about this guy here. What is it that I'm missing here? That's right, Sarah.